right. So we learned the difference between chemical versus physical. Let's learn the difference between intensive versus extensive.
Oh, God.
The physical properties of a substance are the characteristics of a substance that can be used to describe it. This is what we learned last time. But there are two types of physical properties. There are extensive properties. Extensive properties are directly related to the size or amount of the sample. And intensive properties are properties that are not related to the size or amount of the sample. They are intrinsic to that object. Y'all know what intrinsic and intensive mean?
No, extensive.
Intrinsic.
Oh.
Have y'all ever heard the word intrinsic?
I know intrinsic.
And keep your mask on, Cody.
I know what intrinsic.
Intrinsic means it's a natural part of your identity.
Oh, so I'm an eyeballs.
So intrinsic means it's a nature of what you are. It means you have that property no matter what. So there are three primary extensive. Extensive is the opposite. Three primary extensive properties are related to the size of the sample. The first is mass. Mass is related to the amount of matter in a substance. A larger sample has more matter and hence more mass.
You can still hear it.
The next thing is volume. Volume is the amount of space a sample occupies. A smaller sample would take up less space, so volume is extensive. So, does water depend on how much mass it has or how much volume it has?
It depends on if it has H and oxygen.
So, extensive properties doesn't really depend on what material it is. If you have a half gallon of milk versus a full gallon of milk, it's still milk regardless of its mass or volume, yes?
Okay, so can we make water ourselves? Like,
Yes.
we can actually make it so we can
Burn hydrogen with oxygen and it makes H2O.
Okay, so we can never run out of water.
And we could, if we break water into hydrogen and oxygen, the hydrogen will float in outer space eventually. That's how Mars lost all of his water.
Good question. Is that why the ocean has been getting shallower and shallower?
Lots of reasons. So length is the other major one. Length is simply how long a sample is. Y'all quit talking. Width and height are also just lengths. Length measures the size of a sample, so it also is an extensive property. Again, extensive properties don't really depend on what matter you're talking about. If I say I had 5 kilograms of a liquid, would you drink it? I mean, it depends on what the liquid is. Just because I told you it has a mass of 5 kilograms, you have no clue what the liquid is.
It's battery acid. Liquid nitrogen.
If it's water, it's safe. If it's battery acid, it's bad.
Or milk. I like this.
There's also 3 secondary extensive properties that are directly related to mass of a sample. The number of moles of a sample, yes. Is it related to this topic?
Yes, technically.
No. No. The number of moles of a sample is also the measurement of the amount of matter. Has anyone heard of moles referring to chemistry and physics?
No.
Moles is a counting number, kind of. So if I told you I had a dozen eggs, how many eggs do I have?
It does 12. 12.
12. So dozen is a counting number. It's a counting unit. It just means I have 12 of something. So if I have a dozen, that means I have 12. If I have half a dozen, that means I have 6.
I'm tired.
So I know you can't see it right now. 1 dozen equals 12 of something. So if you have 1 dozen of something, it's equal to 12 of something. If you have 1 mole of something, you have 6.02214 times 10 to the 23 of something.
Do we need to remember that?
Maybe.
Well, if I don't have to,
I'll remove these last 2 digits. 6.022 is a good enough approximation. 6.022 times 10 to the 23. That is a super big number. To give you an idea of how big that number is, let's see if I can find. I'll look it up later. But if you had a mole of $1 bills and you were to stack them up on each other, they would go to the sun and then to the Pluto and back multiple times. That's a billion, I think. That is a humongous number. There is 1 mole of hydrogen atoms in 1 gram. There is 1 mole of carbon atoms in 12 grams of carbon. So even though that's a very big number, when we're referring to atoms, there's a lot of atoms in a mass. The amount of energy in a sample is directly related to its size. So how much energy something has is extensive. It doesn't depend on the object. And stop tapping. The number of particles is also directly related to grams and moles. A larger sample has more mass, which means it has more atoms, molecules, or ions. There's a nice mnemonic. Do you know what a mnemonic is?
I know what mnemonic is.
Mnemonic is an abbreviation to help you remember. MVL min. If you remember this, these are all your extensive properties. Mass, volume, length, moles, energy, and number of particles. There are several intensive properties that are not related to the size of a sample. Because this list is much larger, you should focus on remembering the extensive list. So an extensive property is something that doesn't change when you change the mass of something. Color. So a gold bar has a gold color to it. If you cut it in half, it still looks golden colored. An ice cube. So the fact that it's a solid, if you cut it in half, you just have 2 more solids. So the fact that it's a solid doesn't depend on mass or the size of it. Density. Density of water is 1 gram per cubic centimeter. It doesn't matter if you have a gallon or a tiny drop. The density stays the same. Remember that density is mass divided by volume. Though mass is extensive and volume is extensive, whenever you divide them, it's not extensive. So here's an example. If you have a mass of 17.5 grams and a volume of 13, that's a density of 1.35 grams per cubic centimeter. If you were to reduce the mass to 8.75 grams, you would also reduce the volume down to 6.5 cubic centimeters. But the density will still be 1.35 grams per cubic centimeter. Likewise, if you increase the mass to 35 grams, the volume would also increase too, but the density doesn't change. Because it is a relationship between mass and volume, it is independent of both. That makes it... Stop talking. That makes density an intensive property. Temperature is also intensive. This is because temperature of a sample depends on its surroundings, not size. Ice is at 0 degrees Celsius. Doesn't matter how much ice you have. It will, if you remove some of the ice, it'll still be at the same temperature. Some elements like copper and aluminum can appear in a number of different shapes. A substance that can be drawn out, especially into wires, is called what property?
Malleability.
Mm-hmm.
No. Ductile? No.
What is it?
Ductile?
Yes, ductile.
Oh, I got that wrong.
A substance that can be drawn out into wires. That's how we make copper wire, is we can draw it out and turn it into a wire shape. A substance that can be bent or flattened, especially into thin sheets, is called malleability. Gold is probably one of the most malleable substances. You can hammer gold into a single atom thick foil, or only a few atoms thick. Some elements are attracted to magnets.
Cardboard boxes to use for your floats. There's going to be some sitting out in front of the cafeteria there in the little foyer area in front of the cafeteria available to pick up anytime.
Keep your mask on, Cody.
Can I be in a gold box?
So some elements are attracted to magnets and they can be made into magnets themselves. It doesn't matter what size pieces there are in the magnetic material or metal, they will always be drawn to the magnet.
I got a question.
Yes.
What is that? The metal thing?
I don't know.
Okay, I have another question. Since you just helped. So blood, it has iron in it.
Yes.
Iron is considered metal. So can you put
Yes.
a high-powered magnet to your blood and suck it out?
No. But you can attract the iron out of your blood. Yes, you can. So it wouldn't probably pull your blood out, but it would pull the iron.
Yeah, iron will help. What happens if you have blood that doesn't have iron? So
You'd be dead.
that's iron deficiency. You get sick. So Magneto is the best. No way.
So out of the metals, there are only 3 ferromagnetic ones: iron, cobalt, and nickel. Not only are they attracted to magnets, they can become permanent magnets themselves. They're known as the iron triad because they're all next to iron. Iron is probably the most ferromagnetic. Anything made out of iron will definitely attract to a magnet. So let's sort these between intensive or extensive. Remember, intensive doesn't depend on size. Extensive does. So color, intensive or extensive. Odor. Guys, everyone answer. Odor, intensive or extensive? Intensive. Rotten eggs smell bad. It doesn't matter how many you have. Melting point. Intensive. Water boils at 100 degrees Celsius. It doesn't matter how much water you have. Mass. Extensive. Boiling point. Intensive. Doesn't depend on size. Volume. Density. Intensive. Doesn't depend on size. Length. Specific heat. Intensive. Doesn't depend on size. Temperature is intensive. Energy. Extensive. It depends on size. State of matter. Something is solid regardless of size. If you can describe it without mentioning the size, it's intensive. Yes.
We've been over here and now wake up to the minute.
Alright, today was a short lesson.
Can I sleep now? Thank you. I didn't say